Okay, so now we'll talk about multiplying complex numbers. So we have the imaginary unit I. The imaginary unit I is the square root of -1, and it's the number whose square is -1. So when you square this number, you get -1. This number is then by definition the square root of -1. So the square root of -1 is the number that when you multiply it by itself, you get -1 as the result. So we already know that we should get -1 as the result. Let's see what happens if we use the rule that we know for real numbers. The rule says if the nth root of A and the nth root of B are real numbers, then the nth root of A times the nth root of B is equal to the nth root of A times B. That's what the product rule says for multiplying real numbers together as radicals. Now, if we try that rule with these two imaginary numbers, we get the square root of -1 times -1, or the square root of 1, which is 1. And we know that that's not true. We know that that's not what this should equal. By definition, the square root of -1, when I multiply it by itself, should give me -1. So we can't use that rule, and we should know we can't use that rule because right off the bat, this rule says if this nth root of A and the nth root of B are real numbers. So we can't use this because that one is for real numbers. Let's get rid of it. We're not dealing with real numbers, you don't apply. So we use different rules when we're not dealing with real numbers, which means all this crap here, that's not true. That's a lie. We know that the answer for this is not 1, it's -1. And the reason being is because these numbers are not real numbers. How can you tell? Whenever a radical has an index that's even and a radicand that is negative, then the answer is imaginary. So in this case, the index is 2 because it's a square root, and the radicand is -1. So this is definitely an imaginary number. Whenever you have an imaginary number, the square root of -1 factor should be written as I. That way, you won't use the wrong rule. You see, if you keep it the other way, you might end up using the wrong rule and getting the wrong answer. So that's why this leads to I squared, and by definition, I squared is -1, and that's the correct answer. So anytime you have an even index with a negative number underneath, you're going to have an imaginary number, and when you multiply them, you have to see the factors of I. If you don't see the factors of I, very easy to get the wrong answer. So for instance here, once again, we can't use the rules for multiplying real numbers because these are not real. Even index, negative radicand. This one is the square root of -1 times the square root of 2. And the second one is the square root of -1 times the square root of 10. We needed to isolate these i's so we wouldn't use the wrong multiplication rules. This I also, so we wouldn't use the wrong multiplication rules. So overall here, what do we get? Let's see. That I times I makes I squared, and the square root of 2 times the square root of 10 makes the square root of 20. But we do want to simplify this. Let me see, I squared we know is -1, so this is negative. We're also going to break this up into the square root of 4 times the square root of 5. So the final answer then is -2 square roots of 5. So it turns out that when we multiply these two imaginary numbers together, even though they have the same sign, the answer is negative. The answer is negative. All right. So that's how we multiply imaginary numbers. We have to remember the factor of I. So the factor of I sometimes is already given to us. So those are imaginary numbers. That's an imaginary number. That's an imaginary part of this number. Altogether, this number is a complex number because it has the real part. The real part is 3, and it has an imaginary part, negative 4i. So a number that combines a real part and an imaginary part is neither fully real nor fully imaginary. It's a non-real complex number. All right, so let's see. We distribute here. This looks like distribution. Why wouldn't it be? So we distribute. Let me see. That first one, 5i times 3, is exactly what you think it would be, 15i. 15i. That second one, 5i times negative 4i, is negative 20i squared. But you have to remember that the factor I squared is equal to negative 1. So we get 15i plus 20. But they often like you to write it in a certain form. The form that they like you to write these in is the form a plus bi, with the real number first and the imaginary number second. So let's write it that way. So 20 is the real part of this number, and the plus 15i is the imaginary part. So that would be the product of that imaginary number and that non-real complex number. All right, let's try another one. Here we have two non-real complex numbers. Neither one is fully real nor fully imaginary. So we FOIL this. This is obviously FOIL, right? This times this, then this times this, and then we also get this times this, and this times this. All right, so let's see. That's going to be negative 21 plus 15i, and then that's going to be minus 28i and plus 20i squared. Okay, there, we got that. And this thing here, we know what I squared is equal to. So we got this negative 21 plus 15i and this minus 28i, but then I squared is negative 1, and that's negative 1 times 20. That's negative 20, because the I squared is going to be negative 1. And then you just combine the like terms. So let's see like terms. There's a negative 21 and a negative 20, which is negative 41. There's a 15i and a minus 28i. Those are like terms. So what's that going to be? A minus 13i. And there's the answer. When we multiply those two non-real complex numbers together, we get that third non-real complex number. All right, let's try one more. These are special. These are special because they have a special relationship. One is a sum of 8 and 3i. That's the real part and the imaginary part. The other one is a difference of 8 and 3i. So these are conjugates of each other. That's special. These are conjugates. And because they're conjugates, when you multiply them, the middle terms are going to cancel. So 8 times 8 is 64. The outside gives me negative 24i. The inside gives me positive 24i, so they cancel. And last times last gives me negative 9i squared. Negative 9i squared. But I squared is negative 1, remember? So this actually becomes 64 plus 9. 64 plus 9 is 73. Ooh, we get a real number when we multiply those complex conjugates together.